You know, flying in the winter can be absolutely beautiful. You get these incredible views of crisp, snow-covered landscapes, maybe even the northern lights. But for the airplane itself, well, that serene environment is actually a battlefield. There's this invisible fight happening against the elements every single moment. So let's get into it and break down exactly what those fights are. So, what are these hidden fights we're talking about? It's really not just about it being cold. It's about how ice, snow, and even the air itself can fundamentally challenge the very principles of flight. In this explainer, we're going to break down these battles one by one. All right, so the very first battle, it begins way before the engines are even at full power. It happens right here, on the ground. And we're talking about ice. You know, it might look pretty harmless, but believe me, it is one of the biggest threats in cold weather operations. Just take a look at this. On the left, you've got a perfectly clean wing, totally ready for flight. But on the right, that's a wing with just a thin layer of frost. Now, it really doesn't look like much, right? Some pilots say it feels just like sandpaper. But that tiny bit of roughness, it's incredibly dangerous. And this image shows you exactly why. A clean wing lets the air flow over it smoothly, which is what creates lift. But that icy contamination, that sandpaper texture, it completely disrupts the airflow. It basically trips the air up, causing it to separate from the wing's surface. And the result? A huge reduction in lift and a big increase in drag. It can even make the plane stall at a much higher speed and a lower angle of attack than the pilot would ever expect. So to fight this, aviation has a simple, and I mean non-negotiable, rule. It's called the clean aircraft concept, and it means exactly what it sounds like. Before you take off, every single critical surface, we're talking wings, tail, all the control surfaces, has to be completely, absolutely, 100% free of contamination. No exceptions. It's a fundamental law of flight safety. Okay, so if the plane has to be perfectly clean, how do crews actually make that happen? Especially when it's actively snowing or you've got freezing rain coming down. Well, they have a very specific two-part strategy. First up is de-icing. Think of this as the cleaning phase. They spray on a heated fluid that just washes away any ice or snow that's already there. But what if it's still snowing? That's where anti-icing comes in. This is a much thicker, kind of gel-like fluid that sticks to the plane and prevents new ice from forming for a certain amount of time. It's called the holdover time. It's like a countdown clock. The plane has to take off within that window, or it's back to square one. And of course, in the end, the captain makes the final call, giving it one last look to make sure the aircraft is absolutely safe for flight. Okay, let's move to the next battle. The plane is clean, but what about the runway? It might not be. Taking off from a runway that's covered in snow, slush, or ice, well, that presents a whole different set of challenges. Now, your first thought is probably about braking, right? Especially if you have to stop the takeoff for some reason. And yeah, that's a huge deal. But as Airbus points out here, it's also about getting up to speed and, maybe most importantly, directional control. A slippery surface can make keeping a massive airplane tracking straight down that center line incredibly difficult. And check this out. This table really tells the story. On a runway that's just wet, this aircraft can handle a crosswind of up to 39 knots, no problem. But add some wet snow, and that limit plummets to 25 knots. And if that runway is icy, just 15 knots. So what this really means is that as you lose friction, the pilot's ability to fight a push from a sideways wind gets severely, severely limited. Okay, so the plane is off the ground, it's climbing. The fight against ice must be over, right? Wrong. Not even close. Up at 35,000 feet, where the temperatures just plummet, the battle simply enters a new phase. And here's something that really surprises a lot of people. You don't actually need freezing temperatures for ice to form on a plane while it's flying. Icing conditions can exist all the way up to 10 degrees Celsius, that's 50 Fahrenheit, as long as you're flying through visible moisture like clouds. It's because the air accelerating over the wing cools down, and it can chill those water droplets to below freezing right on impact. So, of course, aircraft have their own built-in defense systems to fight back. The main weapon is something called bleed air. It's scorching hot air that's diverted from the engines and piped right to the leading edges of the wings and tail to keep them warm and ice-free. At the same time, all the critical sensors and the cockpit windows are protected by electrical heating systems, kind of like the defroster in your car, just way more powerful, to make sure pilots always have a clear view and accurate info. And it's not just about water turning to ice. On these super long flights over polar regions where outside temperatures can get unimaginably cold, the jet fuel itself can start to freeze. It turns into this gel, like a slushy, that can't flow to the engines. This is a serious threat, and it requires super careful flight planning. Sometimes pilots even have to descend into warmer air for a while, just to keep the fuel from freezing up. So we've covered ice on the ground, on the runway, and in the air. But this last bottle, it's not with frozen water. It's a cognitive one, a challenge where the cold air itself can trick a pilot's most important instrument. And the instrument we're talking about is the altimeter, the one that tells the pilot how high they are. So how on earth can a simple drop in temperature make this absolutely fundamental instrument, well, lie? Well, it all comes down to physics. Imagine the atmosphere is a big column of air. Altimeters work by sensing the pressure in that column to figure out your height. But when air gets really cold, it gets denser, and it actually shrinks. This makes the pressure drop off way faster as you go up. The altimeter doesn't know that, so it misreads this rapid pressure drop and thinks the plane is much, much higher than it really is. There's a classic pilot saying for this: from high to low, look out below. It's a reminder that when you fly from warm air into cold air, your altimeter is reading high, and you are actually lower than you think. Now, you can imagine this is especially dangerous when you're on approach to land. Being a few hundred feet lower than you think you are could be catastrophic. The solution is a procedure called a temperature correction. Pilots use special charts to calculate the error based on the outside temperature, and they apply that correction to all their target altitudes. It's a simple but absolutely critical step to make sure they're safely above any obstacles. So the next time you're on a winter flight and you're looking out the window at that beautiful, frozen world, just remember all the unseen battles that are being fought and won. From the de-icing crews on the ground to the incredible systems in the air and the careful procedures happening in the cockpit. Safety in cold weather flying is never an accident. It's a victory, achieved by design through incredible science, engineering, and human diligence.